At Chi 2010, we presented Prefab. Prefab is a system for reverse engineering graphical interfaces from their pixels. This lets people modify applications independent of their underlying implementations. In other words, it lets us explore the question, what if anybody could modify any interface? Prefab can be useful to the human-computer interaction research community, for example, because it can help researchers test and deploy their interaction techniques in the context of real applications. This video addresses two of the major limitations affecting Prefab and other pixel-based systems: hierarchy and content. We will do this by extending Prefab. Prefab and other pixel-based systems focus on the surface-level appearance of individual widgets. They do not recover the structure of interfaces, and they are unaware of textual content. We improve pixel-based systems by interpreting a hierarchical tree structure where each node in the tree represents some element of the interface. We also identify unpredictable content like text by modeling the backgrounds of widgets and then subtracting their backgrounds from the interface in real time. We will now show a set of demonstrations selected to highlight some of the benefits of interpreting content and hierarchy. Stencils-based tutorials is an interaction technique for presenting tutorials. Let's say, for example, that we'd like a tutorial to help someone download a resume template in Microsoft Office 2010. Stencils-based tutorials is a way to do this. It hides most of the interface, only exposing the widgets that lead to the end of the tutorial, and at each step it describes what to do. Using Prefab and hierarchy, we can implement this idea on arbitrary programs like Office 2010. We don't need a plugin architecture from Office. Our tutorials are based on the pixels of the interface. Interpreting hierarchy makes it easy to script tutorials like this, because we can robustly reference and track widgets using properties of their path in the hierarchy. Some interface elements are used more frequently than others. The ephemeral adaptation technique exploits this to make common widgets easier to spot. It temporarily hides the distracting, less commonly used content, and then fades it in. Here's a prototype made by Finlater and colleagues, the inventors of the technique. Using pixels, we can implement this technique on arbitrary desktop interfaces. For example, here's our implementation of the technique running on a Skype dialog box. We can use the interface hierarchy to automatically monitor how many times users click on widgets so that we can determine what should always be visible. We can render reverse-engineered background over the widgets that we want to hide. We can also translate interfaces to support localization. To do this, we find all of the text in an interface and translate it into the target language. Here we are translating a Google Chrome dialog box from English into French. We can keep the same look and feel as the original application because Prefab models widget background to find the text. We can then overlay widget background to hide the original text, and then render the translated text on top. Now here's the dialogue translated into Spanish. And here's the dialogue translated into lull speak. An additional benefit of our pixel-based representations is that we are now capable of describing all of the pixels of some widgets, meaning that Prefab can be used to re-render widgets in different sizes. In this example, we revisit the Skype dialog box presented in the ephemeral adaptation demo. We used complete descriptions to extend the dialog and add our own tab. We marked each of the widgets in the control with stars. Clicking on a star will add that widget to our new Favorites tab. Prefab can use hierarchy to remember how to find widgets even when they are no longer visible. When the user clicks on a widget in the Favorites tab, Prefab automatically opens the corresponding tab behind the scenes to make that widget visible and interactive. We have presented new pixel-based methods for reverse engineering the content and hierarchy of graphical user interfaces in real time.